Bom dia a todas e todos. Esse é mais um evento do Observatório da Inovação e Competitividade do Instituto de Estudos Avançados. O evento de hoje a gente vai fazer em inglês, porque o Carlos Silva, que é um dos nossos palestrantes, ele fala inglês, então para poder ficar todo mundo na mesma página, a gente optou por fazer esse evento em inglês. Então vou aqui apertar a tecla SAP, tá? So good morning everyone. It's a pleasure to be here, to have you here with us. This is another event of the seminar cycle that is called Challenges and Opportunities of AI, Sectoral Perspectives. And my name is Rodrigo Brandão. I'm one of the responsibles for the Observatory for Innovation that is affiliated with the Institute of Advanced Studies here at USP. And it's a pleasure to have you here because we do believe that the relationship between AI and sustainability has been neglected here in Brazil. So we decided to have this debate to explore some of the challenges in this relationship. But before going to our event and presenting our speakers, I would like to invite Professor Ariplonsky to tell a little bit about AI, about the Institute of Advanced Studies. Professor, it's an honor to have you here with us today.
Thank you very much, Rodrigo. It's an honor for the Institute to receive in the observatory this series of discussions on the challenges and opportunities for artificial intelligence, looking at the substantial industries. It means not only the theory, the questions, but really looking how it can affect and benefit and risks and whatever. What are the challenges, opportunities in different areas? For instance, health was a seminar a few days ago. Now we have a key issue for society, which is sustainability and climate and all what's around. I understand Rodrigo told me that we're going to also deal with the issue very current in Brazil and abroad about carbon credits. It's a very controversial issue, but very important. And I also would like to thank the colleagues who are going to talk, Carlos Silva, and thank you for making us talk in English, in spite of your name being Silva, which obviously would make us guess that you are Portuguese speaking. But if I remember, you are in the US, I imagine. And are you in the US? No?
Yes, I am. Yes, can you hear me?
Yeah, no, yeah. I'm just kidding, because one of the main composers of military marches in the US that is used by the Navy and all other Marines is John Philip de Souza. So, Souza, Silva goes along. Anyhow, going back, thank you, Rodrigo, for you and your so dynamic group at the observatory for organizing these seminars, and it will be relevant for not only what's going to happen in the seminars, but also the connection with the site that was just presented, that you are also part. So welcome. I'll sit down and you'll have the microphone.
Okay. Before inviting Carlos to deliver the first presentation, I would like to thank the institutions that have been supporting us. The seminars that we have been promoting, they have the support of ABIS, the Brazilian Association of Software Companies. We have the support of CNE, the Brazilian Confederation for Industry. We have the support of C4AI, that is the Center for Artificial Intelligence here at USP, and we also have the support of LIC.PR, that is a research group that is connected to CGI, the Brazilian Commission for Internet. So, as Professor Ariplonsky told before, the idea of this this seminar, the idea of this cycle, of this series of seminar, is to promote some connections between different stakeholders to understand the challenges of AI. And it's important to explore the relationship between AI and sustainability, because as we know, AI can be a really useful tool in helping us to address the challenges imposed by climate change. But we also have to understand the social and environmental impacts the technology can impose us, like the mining activity that is necessary for producing the physical components of AI, and the carbon footprint of training machine learning models. So we'll have today the opportunity to discuss these different topics. And how will be the dynamic today? First, Carlos will deliver a 25-minute presentation, and then Gustavo will do the same. And after the two presentations, Miriam will conduct a debate with our speakers, and then our audience will have the chance to make some questions to our speakers and to Miriam as well. So, Carlos, thank you for being here. Let me introduce you before you start your presentation. Carlos Silva is a remote sensing scientist at Pachama. Pachama trains machine learning models using satellite imagery, LiDAR, radar, and field plots to estimate the carbon stored in forests today and into the future. Carlos helps lead the company's efforts to integrate satellite observations into Pachama's evolving platform for high integrity, transparent, and scalable forest carbon crediting. Carlos holds a PhD in remote sensing and global ecology from Brown University and completed a postdoc with NASA's JEDI mission, a spaceborne LiDAR instrument that measures 3D forest structure globally. He also holds a master's degree from Princeton University in Economics and Public Policy and has developed forest carbon projects for both the voluntary and compliance markets. Please, Carlos, the floor is yours.
I'm going to give this in English. Vou dar esta apresentação em inglês, mas queria primeiro dizer muito obrigado pela invitação. O português é minha terceira língua. Falo espanhol, por isso o nome é Carlos Silva. But I'll do this in English for the technical language, so I come across most clearly. But feel free if I can handle some questions in Portuguese if needed. So it's wonderful to be here. I'm going to the presentation I'm going to be giving is largely about how we're trying to modernize carbon markets by, one could say, bringing AI, principally satellite observations, into the process of generating and issuing carbon credits. But the structure of what I want to talk about roughly follow the prompt was given, and I think it's a useful one. And I'll start by describing the problem, what I mean broadly, the environmental problem that we're trying to deal with. That's on one hand, why we think a carbon market could be useful for handling emissions from deforestation. And then the corollary to that is the problems that I assume are well known about the carbon market that excellent press reporting has brought to light over the last several years. So those are sort of the two problems. Second, moving into why we think artificial intelligence, machine learning, or even just more broadly, digital algorithms can be useful for solving some of the root causes that are producing this lack of trust in carbon markets. And then I'll finally talk specifically about some of the challenges. I'll divide that into two buckets. One is actual technical challenges around the machine learning that we try to do. And the second is more of a policy question about how do we then build public trust in the outputs of our algorithms, and how would we integrate those outputs into an actual functioning market. So that's the broad structure. I'll start with the problem. I think, as most people know, but I'd like to just touch on it. Effectively, Pachama as a company and the carbon market in general, at least forest carbon crediting, is really focused on trying to change land use incentives to reduce carbon emissions from deforestation. So we know we still have large global losses of forest annually that not only contribute carbon emissions to the atmosphere, but also obviously threaten the biodiversity and wildlife that inhabits those forests. So that's the really overarching problem that we're trying to solve. This carbon market emerged over the last 10, 20 years as a way to provide a financial incentive that would shift land use decision-making such that one could think about receiving income for conserving or reforesting areas as opposed to cutting them down. The issue is obviously has been, as you see in these press clippings here, some excellent reporting demonstrating issues of overcrediting, the lack of transparency into how credits are generated, and that rightly has caused lack of public trust in this market, and is hampering the ability for this market to scale into the future and to fulfill its promise to potentially change land use incentives and reduce deforestation. And so I'm going to just quickly touch on what are the kind of to give you a flavor of the big problems with the market today. And to do that, it's helpful to start with what is a carbon credit or a carbon offset. And the important is that the simplest heuristic here is to say there's some notions within a project, a land area defined, that there are emissions that occur once that land is enrolled in the carbon market. To know the impact on emissions due to the project, we then want to have an estimate of what would the carbon emissions be in the absence of the project if that landowner had not enrolled their land in the carbon market. So that's obviously, that red box there is really where the root of most of the problems that are the most important problems that are plaguing the market today. There are several others that I'll touch on, but that's really what results in overcrediting. And so if you were to summarize how the market has existed over the last 10 years, it's really when the claim about the emissions in the absence of the project has largely just been based on static projections into the future. And so just to kind of orient you in this slide here, a couple of things. This is just a sort of a fictitious carbon project you'd see in white overlaid. Actually, it's an area in Brazil. On this little inset here with the horizontal pink line, basically the market rules as they've existed over the last 10 years allow you to come in and say, I've got this piece of land. I'm going to take information such as timber prices, maybe local population growth, land use trends. This differs across the different registries that issue credits, but basically you're allowed to say, I'm going to make some prediction into the future. And that prediction, this is now changing a bit, but is allowed to be constant through time. And so if you want to put it more anecdotally, you'd say, given, as in any country in the US, but certainly in Brazil, shifts, for example, in deforestation with political elections or who's in office. So you might make some prediction under certain government, and you would just hold that prediction constant through time, and your crediting would be based on that. Even if something changed through time, so that's this slide here, let's say you've got a new president elected, but there are also all sorts of things that are impossible to predict. You can imagine commodity prices, soy prices. You can imagine recessions related to COVID. You can imagine prices on fertilizer due to the war in Ukraine influencing natural, availability of fertilizer, et cetera. And so all these sorts of things are fundamentally unpredictable that then cause these scenarios that the press have reported where projects are getting too many credits because they're basing their expectation on what the emissions or the deforestation without the project on these very static predictions through time. So there are also that's sort of the big root of the problem in terms of overcrediting. But there are also many things that could just broadly be put into the bucket. They're not so much AI, but just moving to digital software solutions. So right now, carbon is only estimated manually going out in the field by hand, as you see in this photograph. This little inset on the upper right is meant to show that all documentation of calculations that support the issuance of crediting are in large 100-page PDF documents, completely static documents. The numbers you see in the lower left, all of the calculations of the credits. So once you get what I was showing before, the predictions of deforestation, the carbon estimates by hand, all that is done in large Excel spreadsheets that are then handed off to auditors that manually, line by line, check the results. And so that's clearly not either a way to transparently and reproducibly produce crediting estimates. And so that's another sort of bucket of it's sort of more broader than AI, but is crucial for reducing the problems that the market faces today. So let me jump into, as I sort of foreshadowed here, some of the solutions, both the AI and then just largely digital sort of software solutions. So one of the things that I kind of want to clarify is to be sort of realistic about the real contribution potential, if you could fix these carbon market problems and scale the market, what is its potential contribution as a climate solution? It's not going to solve the entire climate problem, but if the figure here, just to orient you, on the lower axis, obviously you have time, on the Y, global emissions. So this obviously this upward sloping line, it depends on all sorts of different population projections, et cetera. But there's a general increasing, we know, carbon emissions through time. To get to this lower than 2 degrees C warming pathway, which is that downward sloping line, let's say is the Paris Agreement, you need to reduce emissions by that gray triangle in between the two lines. Now, there's been some good papers showing that if the price on carbon were $100 per ton, this orange rectangle is roughly globally, obviously a very rough estimate of the type of contribution you might get from both sequestering carbon from the atmosphere through reforestation and avoiding deforestation emissions to the atmosphere. But I want to be very clear, this is a very radical change. Getting this this green sliver implies driving net deforestation to zero, so that the net forest change on the planet remaining constant. And then also, that's of existing forest cover, and then reforesting an area around 10 times the size of the state of Texas. And I should have brought an example to put that in terms of Brazilian or South American terms. But a very large area would need to be reforested to even produce that green bar. So our goal is, and I want to make clear, today's market relative to what that green bar is, it's only about 1%. And that is assuming that all of the credits issued today are of quality. And obviously the reporting, we know that's not the case. And then even Pachama, we can talk a bit about what we do in terms of evaluating existing projects, but our rough historical record, we only approve about 1/4, 25% of the projects would meet our quality standard. So really, we're talking about several hundred X to make a meaningful contribution of that green rectangle to the climate problem. Here quickly on what do we mean by digital algorithms in general? I'll now show you some specific examples, but we're talking about, on the lower, you see 3-dimensional renderings of forest derived from aircraft. So that's airborne LiDAR. On the upper left, you're seeing a carbon map. There's a value of carbon in each pixel over an area in the northeastern US. And then, obviously, these deforestation maps, what you see in red on the right. So moving away from these manual calculations in Excel spreadsheets to an algorithm that produces pixel level estimates. And I'll talk to you about then validation of those estimates and how we produce confidence in that. So quickly, just to give you a sense of where the market might look like under this shift to a more AI and algorithmic view, we would think of something like you've got your baseline, the emissions in the absence of the project emissions. We can talk about leakage later, but it's essentially, we want to account for the notion that if you stop deforestation within a project, you might just be shifting it from inside to outside of the project. You're not actually reducing deforestation, you're just moving it from point A to point B. And so you need several core map layers to run these calculations. And really what those layers are, you have carbon mapping, forest loss mapping, you can combine them. I'll talk about in a moment how we algorithmically select a baseline. You'd have baseline emissions. The same for the project. You would have a carbon map plus forest loss map, a project boundary. You can extract those pixels and come up with project emissions. And then leakage is a more complicated subject to talk about another matter, but at a very minimum, very simple and rudimentary and not particularly satisfactory approach is to just look at changes in deforestation directly outside of the project, but you could also do the same. And so with these few core remote map layers, you can output these core crediting quantities. And I want to talk in this final, give you a bit more of the insight in some of the kind of the machine learning about producing those core outputs, but then also that's the technical element, but then the policy element, getting it. I just showed you these 3 maps. Why should you believe they're of any quality coming from Pachama or for anybody, from any other group that we can rely on them to produce reliable emissions estimates and ultimately credit issuance. And so the big message here for a general audience is satellites don't directly measure any of these things, even carbon. There's no satellite that can directly measure carbon. And so really what that involves, and this is what a lot of our effort at Pachama is about, is taking, as I was showing on the upper those are three-dimensional renderings of forests that you can acquire from aircraft. The second image here of JEDI is the NASA instrument that I was a part of the team for my postdoc. And what it really does is it shoots like a laser pointer, shoots a beam of light from the space station, and that penetrates the canopy, bounces off the ground. And so what you see here is essentially two examples. It produces a vertical profile of the forest. And this is actually of an area of a redwood forest in California. So that's what you can see. It's basically the ground is this large signal on the bottom, and then you see the top of the tree at roughly 70 meters here, and you can know sort of the distribution of leaf mass between the ground and the top of the tree, and then also still using the classical measurements of tree diameter and height. Taking those spatially sparse, we don't have those everywhere, we just have them in randomly sampled locations on the Earth's surface. Then taking satellite observations where we do have wall-to-wall coverage, meaning for an entire area, we would have a pixel in every point, and that there are many, many types of satellite observations that we can discuss if there's interest, but then it's combining that using machine learning to then output, here's an example for the state of Pará in Brazil, a map of canopy height. That's obviously a precursor to getting from height to then carbon in the forest, but this is the ultimate output, annual maps of height or carbon to then power the kind of core crediting equation that I was showing you earlier. I'll quickly, Rodrigo, on time, how much do I have? I don't want to go just to be...
You have 10 minutes.
10 minutes, okay, that's perfect, fantastic. Then to give you a bit on the baseline. And so this is really, as I was saying, the crux of the problem with the market. One, there are two separate policy approaches to dealing with this, and I'll just focus on one, which is at the project level. And we've really wanted to try to remove as many assumptions as possible in the computation of a baseline. And so we've recast the problem, and there are a number of groups that are trying to do this, as what you would do with any pharmaceutical trial or a standard experiment. And so set up essentially a treatment group and a control group. The treatment group being the project itself, and the control group being an area that is matched to the project in as many possible variables as possible, but that is not enrolled in the carbon market. In the same way that if you were going to test, for example, the efficacy of a COVID vaccine, or any vaccine for that matter, or a drug, you would have a group that received the drug or the vaccine, and then a group that did not. And obviously in that group, that control group that does not receive the vaccine, you don't want to be comparing 25-year-olds receiving the vaccine to 70-year-olds in your control group. So you want this notion of matching between the two groups. And I can talk if there's interest later, but we do test to ensure we use placebos. That effectively means, I'll say that for later, but we can test that hypothesis of how well does our control entry, or excuse me, the project and control group match. But for the moment, just for how does this baseline work, we have a carbon project here in white with each of the pixels denoted in blue. We then select a pixel across a search area that matches the project across a range of attributes that we can observe from space. And so there's simple things. For example, we can have maps of deforestation, and you can see this heat map. What is the pixel's distance to the recent deforestation? We can have values in each pixel for that. We can look at topography, for example, the slope and elevation of pixels. Here's rough tree cover density, but ultimately, as I was showing, we could have canopy height or biomass itself, carbon itself. And then with all this suite of covariates, we can then build up, as I was saying, select for every project pixel, a yellow pixel here that matches across that range of attributes. And then we don't have to make any prediction in the future about what's going on. We can just observe through time the forest loss that's occurring in this control area relative to the forest loss that's occurring in the project. And then if we switch then to a time series view, what that looks like, this yellow line is the observed emissions or deforestation within that control area. And so you can see that's dynamic. It can shift through time. If an election occurs and the background deforestation changes, that can be reflected here. If there's a spike or a reduction in soy prices or fertilizer prices, right? The idea is we don't have to try to make any of those predictions. We can simply observe the background trends within the control area, the background land use patterns. We then compare that to the project being in blue. And so the reduction in emissions I was describing, the difference between the treatment and the control, the project and the control, is this shaded area. So on an annual basis, we would compute the credits to be issued as the difference between these blue and yellow line. I can show later, for time, we build up actually an uncertainty interval around that yellow bar, so we can actually compute the uncertainty in our baseline, and we can talk about how you would adjust crediting accordingly in light of uncertainty. So that is good to move into uncertainty, because that's the kind of final slide, 2 slides here I want to close with, is I think is analogous to a lot of other applications of AI in society, whether it be self-driving cars or all sorts of things can imagine. How do you build, transparently convey to the public how accurate or uncertain any of these outputs are? So that's one thing. Then there's another, I think it's related, is getting people to understand uncertainty. People often want to think, hey, we're moving to software and satellites, it's high tech, that things are perfect. And that's why I wanted to kind of point out, you would not be honest if you just said, here's one yellow line. You want to be building up an uncertainty, at least some confidence interval around that. And so it's important for getting people to grasp that this is not, there's uncertainty in any of these AI outputs. And then the last bit about integrating, the market players today aren't really equipped to deal with a lot of these problems. And so I'm going to just describe one of the simple ways we think this could be done, but getting the market to adopt it is another thing. So what we've been advocating is, you can imagine for each of those core maps I was talking about, you could have an independent body that held a validation data set. And I only learned this sort of common practice from some of my machine learning colleagues, where you can imagine a problem, we're trying to detect a cat in an image. Everyone used the same 10 images of cats, how well everyone can test their algorithms against that same validation data set. So do the same thing here. You can very easily have crowd scaling paid groups to manually annotate deforestation. So you can have large databases of deforestation maps manually produced, and then have any deforestation map produced by an algorithm validated against that. There's an academic effort underway, GeoTrees it's called, because the space agencies want to validate their carbon maps. So similarly, you would have both, I was mentioning those airborne three-dimensional restructure images of forest, as well as those plot measurements by hand. You can imagine a large database held globally, independently by another authority that had them sort of at certain locations on the Earth. Here are the carbon values we've measured in that independent fashion, and have any map produced by an entity validated against that. So whether it be Pachama or any other group. What that ultimately, we're trying to get to, that's one thing to sort of describe that in principle. The important thing is, there are projects on the ground, is on the left. This DMRV, I don't want to go into details, but it's digital monitoring, reporting, and verification is sort of the lingo in the carbon market world. So we have, sort of map outputs. There's then this registry issuance. If people are familiar, there's Berra and there are other groups, but that issue the carbon credits, and then they've been sold on a marketplace. So this yellow box is the real piece of going away from just manually auditing spreadsheets. It's what the registries do today, to how do we have more of this output-based independent validation against an independent database. And then the notion would be, for the public, you'd say, okay, I'm buying these carbon credits. I know it's comprised of these 3 terms. And I know here I've just said plus or minus X, plus or minus Y, plus or minus Z%. But you could then, people don't have to know, it's unrealistic to expect the general public to understand the nuances of either satellite observations or machine learning AI, but they can have confidence that the baseline or the carbon map was validated against an independent body that then reported it's uncertain to be plus or minus some percentage. And then there's a question of, how do you want to issue credits conservatively against these uncertainty bands? So hopefully, Rodrigo, I'm near my end. Hopefully that was useful for everyone. I hope I didn't go too fast and in English there. So
no, it was perfect. Thank you. It was really exciting to know the work of Pachama, and it's interesting to know that many questions are similar to challenges that are faced in other areas of AI, because we really need the systems must be auditing in all areas that we use AI. So it's interesting to know the challenges that you've been facing, and also how the technology can help us to address the social impacts and other environmental issues. Carlos, thank you very, very much. So now Gustavo will be delivering another 25-minute presentation. Gustavo, thank you a lot to be here. It's a pleasure to have you here with us. Gustavo holds a bachelor's degree in public administration from FGV, Fundação Getúlio Vargas. He is coordinator of the low carbon economy portfolio at the Climate and Society Institute and advisor to Climate Ventures. He has almost 20 years of experience in the sustainable development, environment, and human rights agenda. He also worked on building financing strategies and structuring conservation projects. He lived for 5 years in the Alto Rio Negro region, in the border region between Brazil, Colombia, and Venezuela, working for the Instituto Socioambiental in partnership with indigenous populations, on topics including fair trade, local development, isolated clean energy systems, climate change, and REDD+, a framework to encourage developing countries to reduce emissions. Gustavo, thank you. The floor is yours.
Thank you, Rodrigo. Well, good morning to everyone who is with us today. Great to be with Miriam again, old partner in various agendas. Nice to meet you, Carlos. I'd like to also thank you to all the team of the Instituto de Estudos Avançados, da USP. It's an honor to be here. Second time I've been here. Last time I've been here quite a while ago, maybe 2015, 14. We were discussing hydropower in the Amazon. Its challenge is to foster social environmental development in the region, and the experiences in other parts of Brazil where it didn't. And it might seem as non-correlated subjects, but in fact they are not as uncorrelated as in fact both energy and AI are human-created technologies, and I tend to think that technologies are agnostic, and they can be either used for good or for bad, depending on how we deal with them and how we instruct them and how we frame them. And that's a little of what I would like to bring to our conversation today. So I'm not an expert on AI. I'm a curious follower, user. I do have a background in technology. I was a developer when I was a teenager. But the last time I directly worked with technology was in 2005 when I was a manager for electronic banking systems at the ABN AMRO Bank. And then I moved to the Amazon, went to work with indigenous peoples. And despite the fact that I'm still quite nerd and maybe technology is one of my hobbies, it's not something I've been directly involved with lately. But it is a key agenda in the conservation agenda, in the climate agenda, and in most of the subjects I've been more involved since as a practitioner or in philanthropy. So I'll try to offer you a few reflections on that. But probably my contributions are less related to AI itself and more related to environment and the social aspects in the correlations between the application of AI tools to solve the climate crisis. Rodrigo offered some suggestions when we were discussing the seminar today, and he brought into the conversation two of the key lead researchers, and I think they bring very interesting questions to that conversation. One is Dr. Gebru, the founder of DARE. She became quite famous. Most of you heard about her on the press when Google fired her after she presented this letter questioning ethics concerns that she had, as she was Google's AI ethics officer. Especially, I'd like to highlight the problem of AI bias, which she has been raising for a long time. She has a nice paper, which is Race and Gender on AI. Another one is Dr. Crawford, author of the Atlas of AI, whose research also focuses on how human biases like gender, race, and even economic status impact AI training. and how we reinforce such biases as we turn AI and we turn AI into inequality generation machines, as we feed AI with information that comes from society that carries such biases. So I think we have to bring to the conversation of how we frame and we use technology, those historic and cultural perspectives. And Dr. Crawford especially, she brings this perspective that it may sound quite scary to one, as she raises the concerns about the AI bias getting to a level beyond we are probably mostly usually aware of, and maybe looks like more like science fiction to most of us. But the research she's conducting, and also Dr. Gebru, shows that it is happening. It is, especially like when we use AI for like facial recognition of people, for profiling, for things like that. There is very strong research showing the problems, the challenges that are carried up as we train AI with the biases that our society carries. And Dr. Crawford brings this dystopian possibility where AI could exhaust political life and planet resources, where it could even mold our comprehensions about ourselves and our societies. And last but not least, she frames AI as this extractive technology, right? From the minerals that are extracted from the earth, to the work that is extracted from the workers, to the data that is extracted by each and every single post we do on social networks. It's quite dystopian, but I think it's something that we have to be aware of, and only being aware of and only caring for that beforehand, we can actually prevent this dystopian future to materialize. I think there are some points which researchers have been postulating, which are quite scary, as I said, but that we have to take into consideration. One is that AI replicates the biases it was trained with, right? It's not trained, it's not intelligent, it's a trained machine, right? It's machine learning. It's not a machine intelligence. It's still not intelligence itself, despite the fact that we call it AI. It's more machine learning than artificial intelligence, to the point that it is today. In Portuguese, we could say that AI is not inteligente, AI is bitolado, right? A gente bitola o AI, a inteligência artificial, com as informações que a gente usa para treiná-lo. And that leads to AI reinforcing the biases, as the training processes reinforce the pre-existent biases of the society who fed the AI with the data. The other spectrum of thought is this tech savior view that AI will save the planet, maybe even save society from itself. AI could save Homo sapiens from our mistakes because it just does what it's told. So if it's well programmed, maybe it takes decisions better than us. Arguments that AI will be used to ensure we are prepared to deal with climate change, for instance, by predicting climate disasters, or that AI could make possible for our food systems to improve, as allowing us to reduce food waste, ending hunger, predicting harvests, freeing the workers from repetitive work, all kinds of claims, which are, in fact, not new or exclusive to AI, right? We tend to do savior claims to most of the new technologies we developed. I think probably someone might have said the same about fire, right? When first humans got access to fire, and we don't know how it happened, maybe the Greek tale or mythology of Prometheus bringing fire to humans might be right. He was punished by the gods for that. But the thing is that the humans probably, when they got the fire, said, oh, now we're going to be able to cook. Now we'll be able to burn forests and clear land easily. And maybe we'll have a good society. And we've seen in recent years fire being used unscrupulous to destroy forests in the Amazon that should be conserved. We even had the Day of the Fire in September 2019. So any technology from fire to AI can be used for good or for evil, depending on how we deal with that. And I think that's important for us to understand. It doesn't mean that AI cannot be used. And Carlos, I think, has presented various potential good uses of AI to scale the potential for forestry, carbon markets, data analysis, evaluations, validation of projects. And indeed, AI could produce accurate, replicable analysis. And how biased or unbiased it will be depends on how we feed it. So there, I'd like to introduce some of the environmental challenges. I said I was going to talk more about the environmental and climate perspective than the AI itself, especially the climate crisis, right? It's the large catastrophe of our generation. It's a slowly unfolding global crisis, right? It's not acute as the pandemic. It's a chronic crisis that slowly unfolds itself, something that science has been warning us for decades now, almost half a century, something that we've been monitoring and learning and producing good quality science every day. But the thing is, in broad terms, it's the result of changes in the atmosphere composition created by humans since the Industrial Revolution, and is producing a climate system instability at global level with local impacts we are just starting to suffer. We now have maybe since 2023, and future will tell, right? But maybe we can say that now we have a cyclone season in southern Brazil. At least it's what this year is showing us. Let's see how it will happen again in the next coming years, especially in El Nino years when we have global Atlantic waters or ocean waters warming. And all this energy that's accumulated in oceans has been fueling these cyclones in the south of Brazil, as usually and more traditionally, it already fed hurricanes in the North Atlantic. The thing is, there is apparently very strong evidences that a new climate normal has been established or is in the early years of establishment. Impacts that we expected for the next decade have been already occurring in the last half a decade. It is scary also, and we should be worried about it. It's not a coincidence that young activists, very young, right? Pre-university aged youth have been striking globally and have been warning decision makers that our house is on fire, literally, right? The planet is literally, forests are burning, oceans are, well, not boiling like literally yet, but at record temperatures, and the impact we are seeing already with great loss of lives and property. But beyond what we are already seeing in these early days of the Anthropocene, where geology has been supplanted by anthropic factors, Homo sapiens is quickly being impacted by the planet to mold it at a scale where we have not seen yet. This climate crisis, which obviously we will naturally look for divine technologies as an exit way. And AI is one of those technologies. And there is a lot of predictions of AI uses that would solve the climate crisis. One of them, which is the one that maybe scares me the most, and it's not linked to what Carlos presented, because I think the uses that Carlos, it's important to highlight that the uses that Carlos offers us are very useful and maybe not so harming potentially, even if badly trained, right? If you train AI badly to do a forest inventory or something like that, or to calculate the mass of carbon density that was captured in an area or maintained and preserve it. The worst case scenario, you will get overstated data and you will generate more carbon credits than there should be in this area. And that could happen with humans doing it too. In fact, it does, right? That's the crisis we have with VEHA in terms of integrity of a voluntary carbon market. But imagine a future where we have to rely on geoengineering, a future where humans decide that we are going to solve the climate crisis by spraying aerosols in the stratosphere, by flying airplanes and aerosoling the stratosphere with sulfur. That's one of the techs that we are starting to test, right? We already have an experiment going on in the US doing it. And because it's so cheap to do it, like a very rich person, a very billionaire person, maybe like people like Bill Gates, Elon Musk, you name it, one of the Forbes billionaire, those guys, they would have the capacity, the financial means to do it by themselves. They wouldn't have to rely on a country. Or even like a medium income country could do it. You don't have to be a superpower to spray the atmosphere with sulfur. So it raises a big question of governance. If we are going to go for some kind of geoengineering in this century, who is going to govern it? Is it the United Nations, who have been proving not to be able to govern not even land, as war in Ukraine shows, and the cause of Security Council restructuring also? Or, and there are people who are highlighting this potential, could that be an army of drones managed by AI, which would take any bias from any country or any bias from any individual on running it, and so ensuring that would produce the best result for society in its code? This could be a future not so far from where we are today. But then who's going to program this AI? Who's going to feed this AI with the data? Who's going to support this AI with the food for training it so that it can actually analyze and decide when to spray, where, and what are the expected results? And how will this AI actually decide what to do when there are potential outcomes which impact people in different ways? When some country or some region might benefit from the reduction of the heat from the sun, while other might lose something with that. Those are all ethical questions that I think are raised, and that we should take into consideration in this debate of how we can actually apply AI to solve the climate crisis. And I think Rodrigo wants to tell me that my time is done.
Yeah, I'm about to do that. You have 5 minutes if you want.
No, I think I made the point. We can save those minutes for the debate.
Oh, that's great. So thank you very much, Gustavo. It was a very rich presentation, so thank you a lot. So I would like to invite now Miriam Garcia to pose to our speakers some challenging questions in order to make a debate here. So Miriam holds a PhD in International Relations from the Institute of International Relations of the University of São Paulo, a master's degree in International Relations with emphasis on sustainable development and environment from Sciences Po, and a bachelor's degree in International Relations from PUC São Paulo. Miriam is Associate Director for Political Engagement at CDP Latin America. CDP is a not-for-profit charity that runs the global disclosure system for investors, companies, cities, states, and regions to manage the carbon emission. I believe it's that. Miriam, please, you have the floor. Make your comments on the presentations. Pose our speakers some challenging questions. Please go ahead. You have like 30, 40 minutes, Miriam.
Thank you, Rodrigo. Hello, everyone. Good morning. It's a pleasure to be here today. I just know 2 years ago, but it was in the middle of the pandemic, so I still have the feeling that I'm attached to the University of São Paulo because of my PhD. So I was very much pleased to receive Rodrigo's invitation to be a debater about artificial intelligence and sustainability. As Rodrigo presented, all my background is related to international relations, political science. So not a scientist on the hard part of it to understand the development of artificial intelligence, but someone that is learning and reading a lot, because I truly believe that artificial intelligence, as any other big developments that we have seen as society, will impact us. And when Carlos presented the political challenges of artificial intelligence, I was thinking those are not only related to artificial intelligence. Those challenges we saw for the vaccines, for example, during COVID. When you said, for example, that how can we deal with independent validation? So for the vaccines, it was quite easy because we relied a lot on how science was built, especially during the 20th century. So like peer reviews and everything else. And I think every scientist was checking because there was updates on new articles and every day. But there was the challenge of how do we build the confidence and trust for the population to accept this new development that was the vaccines during the COVID pandemic. And also, how do we integrate the private and public spheres to make sure that we could deliver this as a common good for humanity? So I think the challenges that we are facing with artificial intelligence can relate to challenges that we've already seen before, and I don't think that we were so successful in delivering those. I think that is a big part of success on how science can move, and then I can relate on what Gustavo said, there is like a big progress in terms of scientific knowledge. There is also progress in terms of how can you allocate a capital to make sure that you're going to find a progress on technologies, but not necessarily progress on how do we build a trust to make sure that this progress will serve the common good or will serve or the challenges that we have as humanity in the 21st century, such as climate change, and how can we make sure that we are going to have, as Gustavo said, a coordination, regulation, or the participation of the state or of the United Nations, or how states coordinate to make sure that this common good of technology can be delivered. And when we think about artificial intelligence and we are talking here about sustainability, but I would like to make a more relation with the environmental part of sustainability. So thinking of climate change and biodiversity conservation, that is for sure like employment, such as Carlos showed to us, like in terms of how we can deal with forest conservation and making sure that we can have carbon credits that are based on high standards and integrity. But also we can use a machine learning to detect floods, so making sure that we can have a disaster management that is deal in a way that will benefit a local population. We can use machine learning to mapping species, so making sure that we know that the biodiversity that we have. We can use artificial intelligence to make sure that we can have more efficiency in circularity in fashion. So there are always there are a range of ways that we can use artificial intelligence to make sure that we can deliver more climate action. And as we are facing a climate crisis right now, a climate emergency right now, using all the technology that we have, it's like the best way that we can do to make sure that we are gonna win this fight in the time that we need. But I think there are still questions that we need to solve. And I think like when I was hearing first Carlos' presentation, and one thing that I would like to ask to you is that when you presented carbon markets, like we know that carbon markets can work both on a regulated way or can work on a voluntary way. So how do you see the artificial intelligence being used as a way to bridge the gap between what is private and what is public, to make sure that the gains artificial intelligence can make for climate action can be used for everyone? So how do you see that in the conversations that you have? What is your perception about how policymakers receive this kind of information? What are the hurdles that we still have to build this gap between academia and policymakers? And then that is my first question.
Sure, thank you. And could clarify, I heard a few things, but one was on the regulatory, like sort of voluntary versus regulated market, then sort of potential benefits of any sort of the things that I show to be more broadly shared. And is that?
Those are the questions. How do you see? Yeah.
Okay. And yeah, and I'll add a few things and feel free if I'm going off. So I think the first is well, in the issue of regulation of the market. I mean that's I think the way I'll say it is any mature market ultimately has a regulatory oversight. That the idea has been groups like BERA do that as a sort of independent oversight body, but let's just say as any financial market, the financial markets would be prone to even more instability as they were, 100 years ago, for the Great Depression, let's say, before there was actually. So I'm not commenting in terms of what Pachama's view on this. But I'm just sort of observing that I don't think any market will achieve a maturity that allows it to have the confidence unless you have a regulatory body that's ensuring that certain standards are met, that auditing standards are met, et cetera. So I'll just say that on the general point, maybe I think you were getting at on benefits. We often get this in terms of, we say, look, one can imagine what is the most rigorous way to compute credits, and then I show, well, that requires all these satellite observations and these more involved algorithms, and how is a small NGO in some part of the world going to be able to originate a carbon project under that? And so I think there is a shift of the paradigm that will take place in that, and that's part of the way the market works now. Is individual projects make calculations and send them off to be audited. The idea is to get to a place where you'd have, and I don't want to be too sort of informal about it, but we often even try to talk about like an Airbnb, where you would have a situation where you can put your land up on this platform, the calculations occur, so it should enable small-scale landowners who now have to spend lots of money finding a project developer, and someone to do all the calculations, that any small scale lander, this is again the vision, the ideal, obviously a lot more complexity, but could upload a boundary file to a system, and that we could then run the algorithms and produce estimates of how much crediting they could receive. Those calculations could then be, as I showed, sent off to a body. So you'd be democratizing access in the sense that you wouldn't, you'd have a more complex system, but the idea would be to make it democratic in that sense. Yeah. So I don't know. I'll stop there because I think you had other things that you were more wanting to get to, but I'll let you clarify.
Yeah, thank you. I think how we democratize the access of artificial intelligence is something that Gustavo also touched during his presentation. And Gustavo, I would like to hear more about what is your opinion also about regulation, because I know it's something that you work from in terms of like a capital markets side of it. How do you see regulation for artificial intelligence? Like Carlos said that he's quite positive on that and that he see benefits. And I would like to hear more. How do you see that we can not only like in terms of a country level, but also like in terms of international aspects? How do you see we could have a more regulation on artificial intelligence, and if it is beneficial from your point of view?
Yeah, well, Miriam, no, I definitely agree with Carlos. We need regulation for artificial intelligence. The challenge, I think, regarding artificial intelligence is where to, first we need to find where to regulate it, right? Of course, there will be initiatives and there are bills running in various jurisdictions regarding regulation of AI use. But with digital technology, we have a new challenge, right? Those technologies, they are in the cloud, they run in the cloud, and it's very hard to limit or restrict access and use of them. Especially in democracies, right? If you are an autocratic government, if you have a giant state-owned firewall, okay, you just lock up some addresses and you make it very hard for your citizens to access. Not impossible, but you can limit it. But in democracies, like we are in Brazil, or in the US, or in Europe, or in various parts of Asia and Africa, supposedly the government is not supposed to limit your access to these technologies. What doesn't mean that we are not supposed to regulate how it can be used and ensure that it can be, the uses that are developed to it are aligned to our constitutional mandates, right? You cannot use, for instance, probably in Brazil already, despite the fact that we don't have specific regulation for that, but you cannot use AI to control a drone to commit a crime, to kill someone, right? You get like a military drone, and there are various producers in the world today, from Brazilian Embraer to American and Russian companies, and you name it, right? They are making it in Ukraine with Chinese parts. You probably can put up one of those with parts you buy on AliExpress today. That would be illegal because the crime would be illegal in that, not the use of AI itself. But the thing is, we don't have a governing body for AI use today. We don't have one in country, in Brazil. We don't have one regionally in the Americas. We don't have one globally at UN level. Should we have one? Probably yes. Where? I have no clue. I don't know if it's a thematic for the Security Council of the UN, if it's a thematic that should be brought into the conversation if we're going to talk about climate specifically at the UNFCCC, or if we're talking about uses of AI for protection of biodiversity, if it should be taken to the CBD. But indeed, some level of regulation will be required, especially as we scale the use of AI to from like generative AI that generates text, right, which is the most wide used today with ChatGPT, Bard, and all the other engines that are arising digitally, to physical uses of AI. being that the uses Carlos has described with Pachama to monitor forests and audit forestry conservation or carbon capture and storage in forests, or being any other uses that there might be out there. We don't even know where AI is being used today, right? I have a big clue that AI is being used, for instance, in various things, which right now are most of the products and services that we are fed through the internet have some level of AI embedded into it. It might be the chatbot, which is AI powered. It might be a system which defines, for instance, values of products and services, which is run by an algorithm, like, for instance, airplane fares, right? It might be the Uber that you call, right? The courier that you hire, all those systems that decide who is going to offer you a service on those platform style of services, they have some level of AI embedded into them. Is there any bias on those AI? Do they choose? Do they discriminate based on race, on gender? I don't know. We don't know. Nobody knows. We don't have a body that is actually running those codes and checking for that is preventing it. Or we don't even have any levels of sanctions that apply if something like that happens. Maybe things like that, this kind of bias, if it relates to any criminal act that is recognized by a jurisdiction, you probably could get into court, right? If, for instance, you find out that a platform style service has a racist bias on the way they appoint service providers to you, this could potentially be brought into courts as a racism crime, a discrimination crime, or something like that, using the legislation that we have, which was not made for AI. But who is going to do this evaluation? Who is going to run this code? Who is going to check this bias? Who is going to produce the reports? Today, we have no entity in Brazil whatsoever that is being dedicated to this kind of regulation. And globally, even less, right? There is this debate. That's a global debate. But so far, that's a laissez-faire market. It's a pre-competitive and unregulated market. And those two things, unregulated and pre-competitive, are quite challenging things because when they happen, we tend to see all kinds of uses. And it's great that today we have, like, Carlos presenting this potential positive impact uses that will produce positive externalities in the fight against climate change. But there might be uses that, even if they are with good intentions, they might produce the opposite results. And I think the most scary part is that we don't even know. Nobody's tracking it. Well, researchers are, right? And they are producing analysis of it, of parts of it, like Dr. Crawford, Dr. Gebru, and many others. But we don't have a public entity that is looking at it from a compliance perspective, from a regulatory perspective. And I think this is something we should be worried about, something we should be considering, something the Congress, ultimately, which makes the laws of the country, should have at least a working group learning from and trying to draft future legislation, as well as the court system the judicial system should be watching closely, as it will be important to have, and there are lawyers that are following up close, right? but we should have established formal working groups that would be at this time producing the evidence that we need to inform the best policies that we should enact to regulate use cases and to ensure that it is used for producing positive externalities to society, not negative ones.
Amazing. Thank you, Gustavo. And I think you brought several points that we should look at in terms of governance, in terms of regulation, in terms of compliance, in terms of how do we build artificial intelligence, and in terms of how do we build artificial intelligence, I would like to ask Carlos for more clarity. If you could explain like artificial intelligence for dummies, especially in terms of how do you integrate public and private databases, for example, to build artificial intelligence? Because I think one of the slides that you were showing in one of your presentations, you said, oh, these are NASA data points that we can collect. So I am assuming those are public. And then there is also like, as you said, I still need to have someone in there like measuring the tree, so we can have this also as a database that you integrate it to the machine learning. So how does it work in terms of integration of what is public database to what is private database, and how do you try to make sure that you have a less bias in the way those databases are integrated?
Yeah, so the majority, actually, we've only recently gotten into acquiring our own data, and so a lot of what we do is all publicly available. So all of the satellite observations are either NASA or European Space Agency or Japanese Space Agency. So all the publicly available data sets. There are Planet Labs, a private satellite constellation, which is it's even expensive for us to acquire as a small startup. So we haven't been working as much as we might like to. In terms of then that's sort of from space. In terms of aircraft and on the ground, there are also a lot of public. There's not much public. There are academic research groups that went out in the field and took those measurements. Often those are not public, not for any reason other than for researchers not wanting to necessarily share their data. There are public inventories then, so the national forest inventories that the U.S. does, Mexico. We have a large database from, it is Embrapa or INPE, I can't remember, but both of airborne LiDAR collected by the government of Brazil, we domestically in the US as well. So almost we as Pachama have gone for a few projects and flown some aircraft or drones to collect LiDAR and done some of our own plots. We've only done it a few times. In principle, we could potentially put that data. We haven't yet formally like made a policy, but I guess the short answer is most of what we're doing is publicly available. Our ideal would be the case. I think the initiative I did mention is an interesting one that's being led by this group called GeoTrees, because they obviously, for the academic reasons, want that to be completely publicly available. We favor that as well. There's just if that data set, which is again being produced because for research scientific questions like how large is the carbon sink going to persist in forests in the next 100 years. So things that academic institutions and NASA and the European Space Agency and INPE and other agencies, they want to know whether their carbon maps are any good. But we would need to have, from a policy perspective, in order to, for operational use in the market, we need to have a wall between data that would be publicly available that people could use for making carbon maps, to then obviously data we'd want to say, hey, we don't want you to have access to this data because we want it to be independent. When we go check your carbon map, we need that data. You can't use that data to produce your map. So we have a real independent check. So that's a kind of a subtle like data policy issue, but there are challenges like that to figure out. And that's partly where I was getting at, where the bodies that exist today, the registries that exist today, aren't familiar with sort of managing that sort of process. And so you'd need a body that, anyway, I won't go any further, but these are sort of independent of even AI in general. It's just how do you keep independent data sets to ensure impartial validation that's completely, interested parties don't have access to the data. And again, I'm only talking in that validation sense. I'm not talking about any sense of private to keep away from the public. Anyway, so there are ways to do that about but we could think through statistical ways. Anyway, I don't know if that's a useful answer.
Yes, it is. And I do have a follow-up question. How do you see the perception of policymakers? Do you usually talk to policymakers? How do you see their understanding of the impact of artificial intelligence?
Yeah, so we haven't, I was saying in terms of the evolutionary path to maturity of potentially having a regime of actual regulation, at least domestic in the US, we're only seeing that now on the claims that companies can make. So not on the carbon market per se, but if a company wants to say I'm carbon neutral or I do X, Y, and Z, that is now falling under the remit of some of the regulatory bodies. So that's all to say that we haven't yet directly had a lot of conversations with regulatory bodies about the market. We've been more in this earlier stage of just trying to demonstrate how you might get quality crediting, then how you might make it transparent. And I think there's a good comment analogy you made about vaccines, where we always talk about kind of 2 degrees of transparency. One thing is to just say, hey, I got this paper published. Look at, we're really good at carbon mapping. The other is what I'm talking about is that we were trying to show some through the slides. Those are actually some screenshots of like a platform where a user could go in and be like, here's the boundaries of the carbon market. Here's where the control area is selected. I can show you in a moment how we do placebos, but that's where we basically say, take random areas on the landscape that don't have a carbon project, and then we find a control area for them. And because neither that placebo, that fake project, or its control area are enrolled in the carbon market, we would expect, if our matching algorithm is any good, that the outcomes, the deforestation should match between the two. So then it allows us, that's what I was talking about, building up baseline uncertainty. But so the point is, the second set of transparency is like, really to the average person, can you make them be able to see how the calculations are being done, so it's not so much of a black box. And in that, I do want to kind of clarify there is a lot of what we do is not what I want to say. There's a big hype obviously around AI. Now I think it's largely around something like the language interpretation and the image interpretation. Really what we're doing, you don't even necessarily need fancy AI. So there's been a lot of academic research even showing it's really about, because it's sort of a different type of problem. You're essentially doing a statistical problem, which is like, imagine, the simplest form of it is, I know your height and your height and your waist, let's say the diameter of your waist. Can I make some simple linear equation that would predict your weight, your mass? And so now we do that with a tree, but now we have many, many other things, not just the height and the diameter. We've got all sorts of different satellite observations, radar, temperature data, topography. And so it's really about just more than fitting a simple line, finding more complex relationships to make a better prediction of carbon. And so that is technically AI or machine learning, but it's sort of a different thing. So again, to your question about the policy interest really right now is kind of more, I think, on the kind of the AIs that present more of the problems that Gustavo was mentioning, discrimination and other things. Again, the problem we face, and Gustavo mentioned it directly, it is a very important one, which is it is not the same in terms of the order of maybe horrible outcomes, but we don't want a carbon market. One thing is you're just selling paper that's worthless and making money off it, which is not a good thing ethically. That's the worst is the people who are buying these things are purporting to compensate for their emissions. So you're just increasing the amount of carbon in the atmosphere because you're saying, I gave you this piece of paper that says I'm canceling your emissions. That piece of paper turns out to be worthless because your algorithms are junk. So we do want to avoid that sort of outcome. And so, but that's, as I was saying, the policymakers that's still a couple steps ahead of where they really are focused at the moment.
Thank you for the answer. And yes, we wanted them to have integrity because it's a matter of like a climate crisis. We think we are like winning the climate run, but no, we are losing because all those papers they worth nothing. And as the title of the session is Two Sides of a Coin for the Artificial Intelligence for Sustainability Usages, I would like to ask Gustavo, how do you see the role of Latin America as a region for the artificial intelligence, because I think there is a tendency to see the Latin American region as one of providers of critical minerals. So we know that we here in Latin America, we have a lot of reserves for lithium, for copper, for silver, and every kind of critical minerals that we will need to build the machines that will allow the technological progress for artificial intelligence. So how do you think Latin America can be positioned as a region? So to make sure that we are not going to enter once again a extractive cycle, but one that we could also benefit from the progress that this can bring.
Yeah, well, that's a good question. Tough one, Latin American AI. Well, from one perspective, I think, and maybe that's not, I don't have much evidence regarding like investments in Latin America versus investments in the US or in Asia or in Europe regarding AI development. But maybe I think AI we're in a bit better shape than we were, like, for instance, in the ships race, right? If you might remember that maybe couple decades almost ago, Brazil kind of played an attempt to enter the ships race. I think it was still in Lula's first or second term, when we even included ship making into our PAC, right? O Programa de Aceleração do Crescimento. It never flew, right? We still don't have a ship maker in Brazil. Brazil is not part of the ships race. It's still the US, which is trying to catch up, China, and mostly Taiwan, which is the greatest supplier of microchips, if I'm not wrong, and the Netherlands, as they are the producers of the ship-making machines. They are in a whole new level of manufacturing technology that we are not part of. But in AI, we do have a role, right? I think especially because of the role played by Federal University of Minas Gerais, where they did develop a lot of technology. They even developed startups that were acquired by Google. Google has one of its labs in Brazil, one of the few research labs outside of the US that even has potential to change the codes of the algorithms of the Google search engine. So there is a role being played in the region. I know that Brazil has been getting most of the funding for AI research in the region, something like, according to the IDB, something like 40% of the investments in AI in the region have been coming to Brazil. That's not most different than investments in general, so it's not like Brazil is getting right? We are half of the region in GDP, half of the region in population, roughly, right? And we're getting almost half of the investments in AI, what seems to me something as natural. And the region has been also a barn of innovation in digital technologies, especially for use cases like platform services. Many of the platform services evolved either in Brazil, Mexico, Colombia, services that have then spread to other countries in the region, some even globally. The region has also captured venture capital investments. And there I would like to make an observation, which is we don't have much data that does this kind of break analysis regarding global versus regions versus country. But what the data we have from Brazil is quite impressive. Like, for instance, if you look for climate solutions providers, startups that are developing and providing climate solutions, Climate Ventures has been mapping that over the last half a decade. And the last data that I took account of, we have over 1,500 1.500, right? Startups in Brazil which are providers of climate solutions. Many of them, like around roughly 1/3 of it, is related to urban environment climate solutions. So it might be connected to transportation or to sanitation or to waste management, circular economy, and things like that. Roughly another third is nature-based solutions, and that might be linked to forestry, regenerative agriculture, sustainable production from like cattle ranching, sustainable cattle ranching. It might sound strange to have sustainable and cattle ranching in the same phrase, but it is possible, right? There are even like models for regenerative agriculture, which includes cattle ranching in some level, not by itself. So the thing is, there's a lot of innovation in Brazil. There is a lot of innovation in climate tech in Brazil, and there are some of those companies which are making use of AI. Most of them are not high tech, right? Brazil is not Silicon Valley, and I think we have to understand it. Where are our comparative advantages that we can turn into competitive advantages? We don't have the same level of investments that the Silicon Valley that has in AI. We don't have the AI startups which are leading the race of generative AI here. But we do have lots of companies which are making use of the technology in their systems, in their decision-making, in their interactions with the market. We had over the last year, I'd say, or last couple of years, the launch of at least 3 large startups. I say large startups, it might seem like a nonsense phrase, but those are startups that they were born already with hundreds of millions leverage in pledged investments for forest restoration, right? If we call like a Regreen, Mombach, MyCarbon, all with heavy investors behind them, all with very ambitious targets in terms of forest restoration, all of them in the 1 million hectares size of where they want to be in a decade. And this will require technology, right? If you want to restore 1 million hectares for a company looking for that, you will need all technology you can use, even for finding the areas, you know. Like Carlos focused more on like the development of the project for carbon itself, but finding the area, if you are looking not for a forested area, but for a degraded area you want to restore, you have to find it. And you have a continental-sized country with 8,500 square kilometers. Where are the areas I should focus on? Where can I attain scale at the lowest potential cost, right? Where are the areas I can buy cheap, or I can partner with the producers because they are underutilized, and I can get them, and I can get the best cost benefit in terms of how much I'm going to spend to restore this area. As the costs will impact the price, I can actually value the carbon credits I might want to generate, or the non-timber forest products I might want to explore, or even sustainable harvesting of timber, which is something that is feasible by Brazilian legislation to consider. Are then in São Paulo state, where we have the most deforested biome, the Mata Atlântica, the cloud forest, are then in the Cerrado, in the savannas, where we have the widest spread of agriculture, are then in the Amazon, the south of the Amazon or the east of the Amazon, like the deforestation arc, where lots of land have been cleared for pasture and then abandoned because of its low potential. I think AI could be potentially a great contributor to run those kind of landscape analysis. And if you get the data right, it might save a lot of time into positioning operations on the ground and things like that, and to building the arrangements you need for large-scale restoration. We're talking many of those 1,500 startups that are offering climate solutions, they are exploring new fields of new industries, right? New fields of business. Things that before were not considered even spaces for business to enter. They are solving the negative externalities that capitalism has produced by a lack of or not so well developed or not so well implemented regulations. If we had we talked before about regulations, right? If we had good regulations in place, we would not have produced the negative externalities that took our atmospheric composition into disarray and led us to the climate crisis in the first hand. So I think there might be a role for AI there too, and especially in Latin America, where we have such a huge potential for nature-based solutions.
Thank you, Gustavo. Yeah, go ahead.
Following on what Gustavo said, yeah, too. What I do want to point out that in terms of Latin America, Brazil particularly, in terms of the work that we do directly, I had that slide about going from satellite observations to carbon maps, deforestation. Really, actually, INPE, if you're familiar with Map Biomas, is a group, it's a university coalition, is really one of the world leaders in all of that. We actually use a lot of the Map Biomas maps. When I talked about pixel matching to the control area, there are great land use maps. And so we want to say, what is the distance to the nearest pasture, distance to the nearest crops, et cetera. We use Map Biomas all the time. And so anyway, Brazil is a real leader, in particularly on the satellite-based extracting information from satellites for these forest monitoring purposes. The second thing I wanted to follow up is exactly on reforestation, and particularly actually in Mata Atlântica, somewhere we, Pachama, actually have projects that we're working, and for all the things that you just described in detail, Gustavo, we are trying to build up that capacity in terms of scale. So for a number of things, where is it ideal to reforest? There's sort of an ecological question, but there's also the policy. I mentioned leakage earlier. That's a kind of a thorny issue, but at least in the nearest term, we want to be reforesting on degraded lands. You want to be at least avoiding, if we're taking, let's say, productive soy out of production to reforest, it's going to be very difficult to compute whether there's been leakage. That's a whole separate issue, whether it's possible or not. But so what we try to do is avoid having that conversation to begin with and reframe the problem and say, let's at least start reforesting on land that we don't expect will be used for productive agriculture, such that we can have high confidence that we're not just moving the deforestation somewhere else. So all of that identification of ideal spots, and then coming up with estimates of crediting by using local data as well to get some sense of the regrowth. And we're actually focused, I just want to say, yeah, Mata Atlântica happens to be for our first 3-4 projects.
Rodrigo, I think you have the mic.
I'm here. Hey, Miriam, thank you a lot for your questions. I think you made incredible questions and it enriched the debate. I'd like to hear from you, Miriam, because CDP is connected to many different stakeholders, national and international stakeholders. What do you think? Are they aware of the potential of artificial intelligence in tackling climate change? Is this a new topic for them? I would like to hear from you your impressions about the stakeholders' perspectives on AI when it comes to the environmental agenda. Do you think they know AI, they know its potential and its threats? What do you think?
I think there is a lot of hope for the benefits of artificial intelligence. people working with the environmental agenda, with the climate change agenda, is willing to have the best tools to face the problem. So I think there is like a hope, but like from the perspective that I see, especially like in terms of policymakers being on the national, regional, or international level, I think there is still a way to go in terms of understand how this can benefit. I saw one of example of artificial intelligence for international climate negotiations in Bonn during the preparations for COP28 that I found it was amazing. A group of scientists provided like machine learning for all the submissions that parties and non-party stakeholders, so civil society actors, made for the global stocktake. They had more than 100,000 pages to review and to make sure that they were going to read all the submissions that were made in an 18-month project, and they wanted to integrate this on a synthesis report to be presented to policymakers. So I think this was like a usage of artificial intelligence and benefit of international negotiations, and everyone was very like interested to hearing, oh, okay, we were able to process all the submissions made during the public consultations to identify trends in terms of mitigation and adaptation and everything else. I think also when we see risk disaster management, that it's a big agenda for climate change. We can see now with climate extreme events happening everywhere, especially in Brazil, like having the support of artificial intelligence for that is something that like policymakers are just like, please give me data so I can have a better decision making. So the use of data for better decision making, being private or public, is something that we advocate as CDP, and I think all society understand the importance of it. But then, like just to sum up a little bit of what Carlos and Gustavo said, the way that data is built and how then we can use in terms of like a public benefits, I think it's something that we still need to debate on how to use the data. And just to take like a moment to comment on what Carlos and Gustavo answered in the last question on there is possibility for Latin America being like a big player in terms of artificial intelligence for climate use. Like the landscape that Gustavo provided us in terms of what is like Brazil doing in terms of like startups and climate solution and everything else. So this is very positive. But I think like we also need to keep in mind in terms of governance as well. How do we build the technologies? How we build the machines, the hard machines that will allow artificial intelligence to move on, and to debate also the role of like critical minerals and mining and everything else in this like a value chain of artificial intelligence, so we can have the benefits of it without the costs for the environment. So I think that this would be my takeaways from the debate.
Oh, that's great. Carlos, the potential of artificial intelligence to in the carbon market is great, as you talked about today, but it seems to be an expensive technology. What do you think about that? And considering that it may be expensive, can we hope that in the future it will be used by many different stakeholders? What do you think about that? That the price of the technology can be a barrier to making it more common and more used by different stakeholders?
Yeah, I think there are two ways to think of that. Excellent question. So one is sort of what I was suggesting earlier, that for a lot of, I'm trying to think off the top of my head, analogies, and we don't necessarily expect the user to recreate the product or the algorithm itself. It's more democratizing access to something that then you can utilize economies of scale, because there's a platform that again, the market, if it's able to secure its quality such that it can scale, there are projections that are really, really big, in terms of the tens to hundreds of billions of dollars. So you can imagine a world where, like many other markets, a small transaction fee could go, for example, to pay for data acquisition for some of the validation databases I was talking about, to fly the aircraft, to go out in the field, to pay people to take those measurements. So that's the kind of way I think at scale this could work. And so you're not talking so much about people being able to do it themselves, but having access to this platform. There is, though, still interest, and it's maybe unclear about where it can fit in. And I think it's a largely a function of how the decline in cost of the actual sensors that are used. For example, LiDAR in the field now are fairly expensive. So when you fly, drones are cheap, but if you were to put a LiDAR on it, those are coming down in cost. Or even now, there are ways to just have it on a tripod or even on a backpack. And so that what I kind of explain what I mean is you can produce a three-dimensional rendering of even the tree. So that data, you can then compute the volume with the machine very easily. And then if you know the density, you don't even have to use really statistical equations. You go from volume to density. So that's the nearest, as I didn't state earlier, I should have stated, you can't ever measure carbon unless you cut down the tree and weigh it. So when I'm talking about validating these maps to get closer and closer to that ideal, so we get a more rigorous validation, you want to be moving to this reconstruction of the volume of the tree, and then, as I said, apply the density. That's a species specific, so you have a parameter there that still has uncertainty. So all I'm going to say goes to say that I remember someone mentioning to me that GPS units used to be really expensive, and now every iPhone has one, or every smartphone, and they now cost, I don't know how much to produce. They're very cheap. And so right now, to have a backpack that would have a little LiDAR that would enable you to produce that is, upwards in the tens of thousands or maybe even hundreds of thousands of dollars. So you can imagine the sort of participatory data gathering that would more democratic access to these instruments if those costs came down. But I don't, that's just a question of the technology at the time. So yeah, hopefully that's helpful.
Yeah. Okay, Carlos, another question for you. Based on your CV, for instance, it looks hard to find a professional that can develop artificial intelligence applications as the one that are developed by Pachama. How hard is it for Pachama, for another companies, to find a scientist that can develop the technology? Is it really hard in the United States to find someone with the proper background to develop the technology?
So it's a great question. I think there are two things I'll answer. So one, and it gets to some of the comments that Gustavo had made earlier, and some of my earlier comments about a lot of what we're doing. The quality of the output is really more the data, the quality of the data into the algorithm, as opposed to increasingly complex algorithms being needed. And so what I mean by that is today, if we put an announcement, it's relatively easy to get people who know how to build a neural network or do some sort of machine learning algorithm, good programmers. That's not to diminish that, but they know how to build up the algorithm. But if on the input side, there are a whole host of corrections. So I'm giving an example of when a satellite, the energy that's photons that bounce off the Earth and go back to the satellite, it passes, for example, through the atmosphere. And so even if you take a picture, if it's a simple, I'm not even getting into more complicated satellite instruments. If there is haze, if there have been forest fires, for example, aerosols, smoke in the atmosphere, it changes you have to correct for that if you want to get what the actual reading was at the ground. And so I'll just to summarize it up, early on in my tenure, let's just say this way, you can't naively dump in a bunch of satellite observations that you downloaded for the internet into a neural network and expect to get a good biomass map out. And we've shown very clearly that you'll get garbage answers out when you haven't done the proper pre-processing of the satellite observation. So to quickly answer your question then, that subset of scientists, they're out there because they work in the universities, but they often tend to be more academically oriented, and they're less interested in working in the private sector. And so you will need both. You need the neural network builder types, people who understand the machine learning at depth, the AI at depth, but really it's harder for us now to get the scientists on the input side. And then the second final comment I would say is, I consider, as I mentioned, both my undergraduate and master's were in political economy and economics. And so I don't consider myself to be at the forefront of either of those other sides. I'm sort of a competent scientist, but it's not like I've got 10 years of publications. So I kind of sit in this realm where, so some of the questions that Miriam was also mentioning about how do we integrate into the economy, the policy setting, the market, the kind of science and the technology that we're trying to build. So that's also a rare group to be able to find.
Oh, that's great. Gustavo, Miriam mentioned the threat that Latin America can be a country that provides the minerals that are needed to producing the physical part of AI. In your opinion, is there a good framework that we could adopt using partnerships between the private sector and government in order to avoid this threat that Miriam mentioned before?
Yeah, well, I think that's not exclusive to AI, right? And that's something that goes along for all other technologies, for digital technologies, for technologies that we are betting on the transition to a low carbon economy. So that's a problem that I think it goes much further than only the demand of minerals for AI development. In fact, potentially, if we look at this at the challenges in terms of resources, mineral resources sourcing for industry, not that AI won't demand a lot, because of course you need a lot of GPUs, right? Chips to run it. What sets and it's a broad adoption throughout the world will put the demand for chips even higher than it is today. But if we compare that, for instance, with the demand for mineral sourcing for batteries in a scenario of electrification of most of our transportation systems, and even like a transition to renewable sources, which will also require more energy storage if we are dealing mostly with wind and solar, or even with the adoption of hydrogen systems for storage. All those will require a much larger scale of mineral sourcing than AI itself. So I think we gotta put AI into perspective. There is the research community that is focusing on AI. They are looking at this demand for microchips and looking at how it may apply for the supply chains of raw materials. But if we put into perspective comparatively to batteries demands that our future scenarios of decarbonization brings to the table, it's a paramount different level of demand for minerals. So I think we have to consider it, of course, but I think there are other markets that will put much more demand. And in terms of challenges, the challenges are pretty much the same, right? The world has a terrible track record of tracing the origin of minerals. We are in the 21st century with godlike technologies, right? We have handheld devices that hold more computing power than what we had when we created atomic bombs or things like that. But we still haven't solved the sourcing. We still don't know where the minerals that are embedded into any of our devices came from. Many of the raw materials embedded in any of the devices we carry with us and we use might be, in fact, producing terrible impacts into the environment and into societies. And we might connect that to the Brazilian Yanomami crisis, right? Because the beginning of this year, what was unfolded by 4 years of inaction in terms of protecting indigenous lands led us to a situation where we had over 20,000 gold miners illegally digging and destroying the Yanomami indigenous territory in the north of Brazil. The same is happening in other indigenous lands in Brazil, right? Munduruku lands in Tapajós are also infested by gold miners. But it also leads to other regions. If you go to the Democratic Republic of the Congo, DRC, or many African countries, we are observing every year political disarrays, coup d'etat, you name it, wars, all fueled by the profits of mining, or created by disputes over control of mining resources. So establishing a tracing system for ensuring that we know where the supply comes from, for ensuring that the corporations that are acquiring those resources and producing the goods, being it the batteries or the microchips or whatever, or screens and etc. That are needed, it's paramount. As it is paramount for us to trace much more simple things like cattle in the Amazon, right? Because we also don't have we also don't know where the meat from our barbecues come from. So I think like tracing in general, not only for minerals, also for agricultural goods, is a key policy. It is a key policy for the future. It's a key policy for the present, and is a key policy whose lagging has produced many of the environmental challenges and the social challenges we have today.
Oh, that's great. So we are run out of time. So I would like to thank you very much, Miriam, Gustavo, and Carlos. It was great to have you here to have this conversation. I hope this was a good opportunity for you as well. So thank you very much.
Thank you.
Bye bye.
Thank you. Have a great day. Bye.
Thank you, Rodrigo.
Thank
Nice
you.
to meet you.
Bye.
Be with you.